I want to talk about this animation, which is my favorite, Despicable Me, which is the story of a supervillain that wants to steal the moon. And he has a gun that can shrink the moon or shrink everything, and he wants to steal the moon. Okay. The movie scene is here. Yes. He used this gun and pointed to the moon, and moon is going to shrink and become smaller and smaller. If you see, yes. But the main question is that what happens to the mass of the moon? Because in this scene we cannot see that what happens to the mass of the moon. So, yes, we can assume two different cases. Case one is that the gun only affects on the radius of the moon and don't affect on the mass of the moon. So the mass stays the same that currently we have. And case B is that the radius and mass both are shrink together. Means mass is not similar to now again. But in case A, the density is going to be very, very high because lots of mass is concentrated in a very compact object. So, but in one scene after that, we see that the waves of the ocean is become disappeared, and we know that it's because of the tidal force. And tidal force is proportional to mass and inversely proportional to distance cube. Distance is the same as current distance of mass of a moon and Earth, but the mass is the same again in case A, so the tidal force should not be very different. So this case maybe is not the case that a movie wants to say, but it's worth to calculate. I don't know why it's not working. Oh, okay. And these are some of my parameters that I've used in all of the calculations: the mass of the moon, radius, density, and all of these. And also I have assumed that because in one scene we can see that the Gru keep the moon in his hands. So we can assume that it's a palm-sized sphere with around and size of the sphere, size of the palm should be 8 to 9 centimeter, and the radius is going to be 4.5, and we can using that radius, we can calculate the volume. And what happened to the density? So if we calculate the density of this moon, which its mass is conserved and only volume is differ, we can say that its mass is going to 5.76 times 10 to the power 22 times more than the current moon. So practically Gru cannot hold moon in his hand because it's too dense. And what about gravity? For gravity, if we use formula Gm over R square, and we can have the parameters on that, and we compare the gravity to the gravity of the Earth, which is approximately 9.8, we can see that the gravity is 2.45 times 10 to the power 14 more than gravity of the Earth. So surface gravity is really high. So again, Gru cannot keep it in his hand. And we want to talk about the force. If we want to calculate the force, we just should multiply mass of the Gru and the gravity that Gru can feel. And gravity is again that formula, and we can assume that their separation is around 0.25 meter, is just an approximation. And we calculate the force, and by using that force, which is really high, we can calculate the time that group being pulled into the moon. So it's around 10 to the minus 8 s the second, which grew pulled into the moon. So apparently he cannot just held the cute moon in his hand. And because I was curious that this shrinked moon can be a black hole, or if it has some relativistic parameters, I calculate the escape speed, and it's around 5% of the speed of light, and it don't have a really much relativistic effect, so we can use Newtonian formula. And for black hole case, I calculate the Schwarzschild hole radius for the parameters of the moon. It's around 0.1 millimeter, but we assume that the moon is in his hand is 45 millimeter, the radius of the moon. So we can say that this moon is not going to be a black hole. And because, as I said before, because the mass is conserved and the distance is the same distance that we have, so the tidal force should not be changed. Tidal force should be at the same, so that scene that we have seen that the waves of the oceans disappear cannot be true using this case. And if we, for example, use the distance of 1/3, the tidal force should be 27, because the tidal force is related inversely to the distance cubed. So even the tidal force becomes worse, not less, when we move that little moon to the Earth. And what about case B? In case B, we assume that the density is going to be same, but the mass is going to be changed. And if we want to see that, how much mass should the moon release to have that size, we can see that it's practically lose all of the mass that it have, and the tidal effects is also, when we compare them, the tidal effects is disappear. So case B is much more relativistic to the scene of the moon. And for the mass of the moon, by using the formula of density, we can say that the mass of the moon is 1.28 kilogram. So GRU in this case can held the moon in his hand. But what about surface gravity? If we use previous formula for surface gravity, we can see that the surface gravity compared to Earth is really tiny. So practically, again, in this case, GRU can hold the moon in his hand. But the main problem of this case is that what happened to the mass? The moon is apparently almost entire of the mass of the moon is go away, so it's should be go somewhere. It cannot be because of the conservations. It cannot be just quiet and beautiful as movie shows. So one case that we have is that entire mass is going to be energy. It's converted to energy, and if we calculate the formula delta m C2, and we have the parameters, it's a really huge amount of energy, and In this case, if the moon release this kind of energy, GRU cannot be there and will be pulled away very, very violently. So it's one of the cases. And the other cases is that the moon release the mass as kind of some ejecta, some mass. And if we calculate this using the formula, we can see that it's again a really high amount of energy, and GRU cannot be like that and will be burned or will be poured away. So, and if we want just have an approximation of the power of that shrinked moon, and we assume that the shrinking is going to be in 1 hour, we can estimate the power that that moon will be released, and it's just a lower limit. And we can see that it's high amount of power, and we should have seen some astronomical effects in the movie, but we didn't see anything in them. And what would happen to the barycenter? Because moon and Earth are orbits, have an orbit that is related to both of them. And currently in the formula for barycenter is that currently real Earth Moon system is the barycenter is that's 4,670 kilometer, and the Earth radius is 6,071. So the barycenter is not at the center of the moon. It's a little bit different, and the moon and Earth kind of wobble around each other. But if in case B, the moon is lose entire mass, so the barycenter is going to be at the center, as we can see in that case. The barycenter is going to center, and it has some effects on some long-term effects on the system, and it's the effects that we have in long term. It has maybe it has caused some ice age, or some environmental effect, because the moon, the Earth didn't have that wobble that currently have. And so in summary, I should say that we have two cases. In case one, only a radius is going to shrink and mass is the same, so the density is going to high, gravity going to high, but tides effects at the current way that we have. And in case B, both mass and radius is going to shrink, so the density don't change, but the mass is going to be very, very low, and it's about 1.28 kilogram. And tidal forces going to be vanished, but the problem here is that the moon should release lots of energy and ejecta, but we didn't see that case in real life. And I have assumptions here, and my references are this. Thank you so much.
Okay, questions, comments, please? Yes.
It's a very nice topic. I'm curious, in case A, how large a pressure we need to compress the moon into this size? Because
Pressure.
I think that this size would mean millimeter size. That pressure should be come from the proton degeneracy pressure.
Yeah, but in movie it's a mystical gun, so it's kind of it only shows that it's a gun. We don't know anything about the structure, and it's only press everything. I'm not sure about the exact pressure that we need to shrink the moon.
Well, I'm curious. That pressure cannot be maintained. I think that moon will immediately expand again.
Yeah, yeah. And in other scenes of this movie, in the last scenes, they show that moons grow again and come back to the size that we have, but we don't know anything about pressure. Yeah.
Other questions, comments? So, about the Bahareh center, if the Bahareh center goes back to the Earth's center, then what happens?
Currently, Moon and Earth kind of wobble around each other, and Moon have some this kind of effect. If the moons become disappeared, this wobble is going to disappear, and the tilt of current tilt of the Moon may be changed, and it can affect on seasons and the climate of the Earth in long term.
Okay. Any other questions, comments?
With comments I have a following discussion is that because in the case 2, the mass of Moon becomes very, very small. So although the orbit is only relevant to velocity, but because the mass has become very, very small, so any perturbation will change the orbit. So the orbit will become more elliptical, and then I guess in the end of this orbit, it will be catched by the sun.
Yeah, but in the movie, he steal the moon. He keep the moon in his hand and came back to Earth and keep it in his house.
Okay,
So.
I just say in the case that if the moon become very, the mass become very small and maintain in that position to keep going, follow
Yeah.
the original orbit, what will happen in the future? I just try to discuss in this case.
Yeah, maybe the velocity is going to be very higher because I don't know.
Orbit is only relevant to its original velocity. So the only influence factor is the propagation.
I don't know what would happen in that case.
I just talk about something possible scenario about that.
Yes. So, if there is no more question, let's go to Kahoot.
Okay.
I didn't change anything, but it's said that it's up to 10 participants. I don't know why this time.
Okay. We have more than 10 people here?
I don't think so.
Okay. Isn't it a little cold here?
Sorry, it's because of me.
Can I stop?
Yeah, sure.
Maybe there. Everybody joined?
No.
Tell you're not here. Oh, you're in time for the quiz. Could you join? Everybody here?
I'm connected.
Okay. Okay.
Shall we start?
We could wait for.
Oh, okay. So, yes. Okay. Okay. In case A, only radius changed. Yes. Okay. Yes.
In which case?
Case B.
B?
Yes. 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 And last question. Yes. Yes.
Congratulations. Was there any difficult question?
I don't think so. Let me check.
Okay.
Yes.
Any questions about this? No question? Was it clear? Okay, then thank you, Bahareh.
Thank you so much.
Very good presentation.
Thank you so much.
So who wants to go next?